Hello again, my friends. We're going to be talking about bundle branch blocks today. And so let's just kind of pick up where we left off. Last time we talked about axis and axis deviation, as well as calculating the vectors associated with axis deviations. So now we're going to pick up and we're going to talk about bundle branch blocks. So I'm on slide 23 of the PowerPoint here. And the reason that I'm on slide 23 is honestly because I like this picture. And if you know anything by me, about me by now, you have probably figured out that I can't draw to save my life, right? So we're going to use this picture, and I'm just going to kind of annotate on the photo to illustrate my point as to what I'm talking about here. So forget about this hemi block thing and forget about all this stuff right now. I'm not talking about fascicular blocks yet. I just want to focus on this kind of photo right here, okay? Because what we need to understand when we talk about left bundle branch blocks, right? We need to talk about the pathway of the pathway of electricity through the heart, okay? So things are gonna come out the SA node, they're gonna go down the internodal pathways, they're gonna go AV node, AV junction, they're gonna pause for a brief moment, and they're gonna come out, and they're gonna come out the bundle of Hess, okay? And then they're gonna go down the left and the right bundle branch blocks, the left and right bundle branches into the Purkinje fiber, stimulating the ventricles, okay? So if you kind of just look at this photo right here, you kind of see we got the AV node right here, the His bundle right here, and what happens is that the bundles break off into a right bundle branch over here, okay, which innervates, of course, the right ventricle. And then it's going to break off into a left bundle branch, as you can see here. And it's just going to innervate the left ventricle. Now, the left bundle branch is a little different than the right bundle branch because the left bundle branch has an anterior fascicle, as they say, and then a posterior fascicle, as they say. The posterior has a couple of little fingers that come off of it, but it's still a posterior fascicle, okay? So that being said, you can have a blockage of electricity in various places here, right? So if for whatever reason, I made a roadblock right here and electricity could not get past this little X on the right bundle branch, okay, we would say we had a right bundle branch block. So the electricity got blocked going down the right bundle branch somewhere for whatever reason, okay? Now, if we had the same thing conversely on the left side, and we had a blockage right here per se, right? So we would say we have a left bundle branch block. And what are we saying? We're saying that the electricity, for whatever the reason is, the electricity is not able to continue down the pathway of the left bundle branch, okay? Now, things can get a little bit more complicated on the left side because depending on where the block is, if the block's up high like this, it's gonna block the anterior and the posterior fascicle because they're below it, right? But the block doesn't have to be high up here. The block can be a little bit lower. So you might just have a block right here per se. So in that case, the right bundle branch is working fine. The left bundle branch is doing okay. And then coming off the left bundle branch is the posterior fascicle, and that's doing okay. But maybe we just have a blockage of electricity on the anterior fascicle, okay? So in that particular case, we would say we have a left side, which this is the anterior fascicle right here. We would say we have a left anterior fascicular block, okay? And why do we call it a left anterior fascicular block? Because the electricity is being blocked on the left anterior fascicle, okay? That's it. And then, of course, you can have the same thing. You can have a left posterior fascicular block. It just means the electricity is being blocked on that posterior fascicle over here, but it's conducting down the left bundle branch and then down the anterior fascicle just fine, and the right bundle just fine as well, okay? So that is what we mean by left bundle branch block or right bundle branch block, right? Okay, I just wanted to use that photo just to illustrate my point a little bit. So let's back up on the PowerPoint. I want to show you something because this is pretty cool. So let's pay attention here to this kind of morphology, as they say, right here, okay? You're going to notice that on an EKG, instead of things looking like that, right, something might come up and you get a R wave that goes up, and then it kind of does one of these. And notice what we got here. We have a peak right here and a peak right here, okay? You'll notice that there's almost like two little, almost what they call rabbit ears right there, right? So like, well, what's going on? Why would we have a quote unquote double R? Because that's what you're seeing. You got one R and then another R. Oops. And then a T wave, right? So why do I have a double R? Because that's an R wave and that's a second R wave, kind of looking like that, okay? What's happening here is that when you have a bundle branch block, for whatever reason, electricity is not conducting through that left or right bundle, and it's having to migrate through cell-to-cell transmission from the one side that it is traveling to the other side of the heart. So for example, if you have a right bundle branch block, electricity is not getting down that right bundle and innervating the right ventricle. So therefore electricity has to migrate from the left ventricle through cell-to-cell transmission from the left ventricle over to the right ventricle, okay? So what happens is because of that, it takes a little bit of time for that electricity to migrate from the left ventricle to the right ventricle when that right bundle branch is blocked. So what you're seeing here is this first R wave, right, is probably going to be your right ventricle, right? And then your next R wave is probably going to be your left ventricle. So what's happening is that you're seeing that ventricles are depolarizing out of phase with one another. They're not in sync with one another. And that's because that electricity is being blocked on one of the bundles and it's having to migrate through cell-to-cell transmission. So that's common to see on a right bundle branch block. You get what they call a double R, okay? So let's talk about criteria, because just like everything else in EKGs, we have to memorize what the criteria is before we can go looking at something. So let's clear this out, clear the screen here. Give me one moment, and I'm going to share a different screen here. Go to a little. There we go. Let me go to the top here. Okay, so you got three money leads, as they say. Remember how we talked about money leads before when I was talking about axis deviation? I said your two money leads to look at for axis deviation are lead 1 and lead AVF, right? Those are your money leads, okay? So for bundle branch blocks, what we need to do is we need to look at our money leads for bundle branch blocks, and those are going to be V1. Oops. There we go. So V1, lead 1, and V6. V1, lead 1, and V6. So when you're trying to figure out a bundle branch block, okay, you're going to look at V1, lead 1, V6. And then you're going to need to learn the morphologies. So let's back up a second before we start doing bundle branch blocks, right? You always want to have a systematic approach to every EKG, which we've already talked about, okay? So for example, if I was to change the slide, and I bring this slide up right here, okay, this is an EKG, right? And if I was to look at this, and we haven't really got to it yet, but this does have a bundle branch block. But before you go saying, oh, this is a bundle branch block, Well, you got some things to do before all of that. Okay. So this goes back to, like I said, about developing a systematic approach. So a lot of people will go rate, then they'll go rhythm, and then they'll go intervals, right? And then they'll go axis and hypertrophies and blocks, and then ischemia, and they'll kind of follow like order, like that kind of an order, okay? So remember to get a systematic approach. Now, before we look at this EKG, we just got to go back and we got to learn our criteria for what makes a left bundle branch block and what makes a right bundle branch block, okay? It's really easy. You just got to memorize a couple of things, okay? So for me, if I'm looking at a left bundle branch block, I need to identify first that I have wide QRSs. Okay, I need to identify that I have wide QRSs. So I'm not expecting you guys to like, know this yet, of course, right? We're working on it, but I just want to point out that see this guy in V1, this is a wide complex QRS. So when I see a wide complex QRS, the first thing I got to start thinking is, well, if this is wide, why is it wide? Something is abnormal here, okay? Now, if you remember back from your learning of rhythms and arrhythmias and things, one of the things that I told you guys was that if you have a wide QRS, that's usually associated with a ventricular rhythm, okay? But a bundle branch block is not a ventricular rhythm. It's originating above the ventricles, like in, the SA node or something along those lines, right? So the question is how do I determine whether something is a sinus rhythm and has a wide QRS because it has a bundle branch block, or it has a wide QRS because it's a ventricular rhythm, right? That's the question. And I'm going to tell you the answer is you look for P waves. See these P waves right here? You either have them or you don't, okay? So if I have P waves, it's not a ventricular rhythm. It's got to be some sort of atrial rhythm, sinus rhythm, something along those lines. Now, why do I have wide QRSs? Okay, well, that needs to be investigated at this point, okay? So one of the things that I always teach people is if you're not sure, like, hey, is this a bundle branch block or a ventricular rhythm? You need to look for those P waves. And you should be doing that if you're following a systematic approach, okay? All right, so that's just something I wanted to point out to you guys to be able to differentiate between wide complex QRSs that are due to bundle branch blocks and wide QRS complexes that are due to ventricular rhythms. Now, if you haven't thought about it yet, why do we have a wide complex? Okay, well, measuring left to right on the EKG is a measurement of time, right? And if we have a bundle branch block of either way, left or right, it doesn't matter, and things are taking more time to occur, they're going to be wider on the EKG, okay? They'll be wider. See how this QRS is wider, okay? So hopefully that kind of makes a little bit of sense for you guys, all right? So let's learn our criterias, okay? So I always thought of this like in the very beginning when I was learning it all, like a turn signal, okay? If some of y'all don't use turn signals, like you're those people in life that don't use turn signals, maybe this won't make sense to you, but I hope you use turn signals, right? So if you have a left bundle branch block, right, V1 is going to go down. Okay, let me get this. Oops. Hold on 1 second. There we go. Okay. So just so let me write it out for you guys. This would be a left bundle branch block. And this is going to be your right bundle branch block. Okay, there you go. That's a B. I swear it is. Okay. So this side on the left left bundle branch side on the right, right bundle branch. Okay, so notice on V1 here, how it goes down. It's a negative deflection on the left bundle branch block. Notice on the right bundle branch block, how V1 is a positive deflection. It goes up. Okay, that's going to be a hallmark characteristic of a left and a right bundle branch block. So if I just was to ask you a very simple question and I say, hey, V1, left bundle branch block, which way does it go? You should be like, oh, it goes down. If I said, hey, V1, right bundle branch block, which way does it go? You should be like, oh, it goes up. Okay, so it's just like a turn signal, right? If you make a left turn, your turn signal goes down, right? So left bundle branch block, left turn signal, it goes down. If you make a right turn, where does your turn signal go? You move it up to the right, right? Right turn, it goes up, just like V1 goes up, okay? So that's what we mean by the turn signal thing. So you have a couple other things. So I know some people they'll get kind of lazy and they'll just look at V1, and if it's V1 is wide, and they'll be like, well, if it goes down or up, it's left or right, okay? You got to do a little bit more than that, okay? So over here on the left bundle branch block side, we said our money leads are V1, lead 1, and V6. In the left bundle branch block, V1 is going to go down, negative deflection, and it's going to be wide. And then lead 1, you might have a little bit of a double R, or you might not. It can be either or. But if you notice, you don't really have a Q wave here, because remember, a Q wave goes down. You just have basically like an R that comes out of nowhere, and then your S, okay? So that is kind of a hallmark of a left bundle branch block. So additionally, in V6, you'll notice that what? You don't have a Q wave over here either, because Q waves go down, R waves go up, and then back down again. And then your S waves return to the baseline, because that's your Q, that's your R, and that's your S, right? So you got an R wave pretty much only, and an R wave pretty much only in lead 1 and V6. And then in V1, you've got a negative deflection, and it's wide complex. Okay, so that's the criteria pretty much for a left bundle branch block. Now you got to have P waves too. Okay. All right. So right bundle branch block. R, B, B, B. All right. You can have a couple of different morphologies here. You can have kind of like a double R, like you see here. Or sometimes you just have a Q and then just a very wide R and then an S, all right? So it can be either or. So some people will tell you that a right bundle branch block will have these things called rabbit ears. It kind of does look like rabbit ears if their head's turned a little bit, like little bunny ears, okay? That is true. Rabbit ears are associated with a right bundle branch block, but it doesn't always have to have them. So I think in today, some of the examples we looked at, I think that we might have an example or two of a right bundle branch block that has the bunny ears and a right bundle branch block that doesn't have the bunny ears. So it's good to look for it when you see it, but don't rely on that because it might not always be there, okay? So wide QRS in V1, positive deflection, okay? Remember when you're counting your QRS, guys, it doesn't go from here to here. It goes from here to here, okay? Starts at that Q, the very beginning of the Q over here, all right? So remember to do that when you're counting the width of these things. Now, notice in lead 1, we have an R wave that comes up. And what do you notice that's different about this S wave, right? So if you look here, I want to show you this. I'm going to draw on it. See this S wave, guys? They call this a slurred S wave. Then look down here in V6. You see this S wave? They call it a slurred S wave, okay? I've always called them lazy S waves because that's what they look like to me. But the proper term is slurred S waves. What is a slurred S wave? An S wave should be nice and tight, right? So you got the R wave, then you got the S wave, and then back to the baseline T wave, right? See how that it's nice and tight, okay? You shouldn't be able to color all this space in right here. See how I got like a little swimming pool looking thing going on right here? You shouldn't be able to do that, okay? There shouldn't be that much space between the end of the S wave and the R wave. So that's what we call a slurred S wave. So criteria for right bundle branch blocks are going to be wide QRS, positive deflection in V1, RSs that have a slurred S wave in lead one, and QRSs that have a slurred S wave in V6, okay? So that's going to be your criteria for a right bundle branch block. Now, here's the thing, guys. All of this, remember, your QRS should be greater than 0.12 seconds to be considered wide in these particular instances. Let's say, for a sake of argument, this is something that I don't think is in the PowerPoint, but I just want to throw it out there. So if you hear it, you're like, oh, you've heard of it before, right? Let's say you have a QRS width that's less than 0.12, but greater than 0.10. I mean, we're getting really nitpicky here, right? But let's say you have that. Or let's say it doesn't have these criteria, okay? They call that an Ivcd, so just an interventricular conduction delay. So what that means is there is some sort of conduction delay, but it doesn't necessarily meet all the criteria for a left bundle branch block or a right bundle branch block. So just throwing that out there. So if you guys hear it, basically what it is, it's kind of a similar thing to a left or right bundle branch. It just doesn't meet all the criteria. It usually has a problem with lead one or V6 or something like that, not meeting the slurred S waves, or not just having the R only or something along those lines, okay? All right, so all I can say at this point is just kind of memorize it. I know sometimes you got to memorize things, sometimes you got to understand things, sometimes you got to memorize things to understand things, okay? So just go ahead and commit this to memory as to what the criteria for the left and what the criteria for the right bundle branch blocks are, okay? So we are going to clear this and we're going to move on. And this is some tough stuff the first time you look at it. So if you go through this video today and you're kind of looking at it and you're getting a little frustrated, don't feel bad. Almost everybody can't just look at this and instantly get it. It just takes time. This is like, riding a bike when you're a little kid. Like, you're going to fall off the first time. It just happens. So just keep working at it and keep practicing, and then eventually things start to click. All right, so what do we got here, right? Pretty much what we were talking about. So this comes back to our criteria, right? So if we looked at V1, what do we got? A wide QRS, right? And a positive deflection. We've got an R wave in lead one with slurred S waves in lead one. Then we got a QRS with slurred S waves in V6. So this is just highlighting more of the criteria for a right bundle branch block. As you can see, we got some bunny ears right there. And what do we got going on over here? So we've got a wide QRS in V1. Notice there's what? A P wave, which is important, because if there was no P wave, this could be maybe like a ventricular rhythm or something, right? But there is a P wave, so that means it's some sort of sinus rhythm, right? But we have a wide QRS, shouldn't be that wide, okay? And in this particular case, V1 is a negative deflection, it goes down. And what do we say about V1 that goes down in the presence of a wide QRS? If it goes down, it's a left bundle branch block. If it goes up, it's probably a right, okay? So notice then in lead one and then in V6, what do we have? All we have is an R wave. So we don't have a Q wave. We don't have a Q wave, okay? So that's part of the criteria for a left bundle branch block, all right? So we're gonna get into looking at some EKGs here, and we're gonna apply a systematic approach. We're not just going to look at them and go, oh, left bundle, right bundle, kind of like we did with the axis, because the axis, you just have to look at it and see what it is. But the left bundle branch blocks, if you're not careful, you can miss a ventricular rhythm or vice versa, right? And we don't want to make any mistakes, not if we can help them. So let's look at what we got here. All right, so first thing I'm going to do is I'm going to pick a lead, because when I'm looking at a 12 lead and I'm trying to figure out what the lead is, I'm going to look all the way across, right? Or I'm going to look all the way across, right? And in this particular case, I have lead 2 that runs all the way across for me, which is nice. You don't always have that. So it's good because it lets me see uninterrupted what this rhythm is. So first thing I'm going to ask myself, do I have P waves? Yes, I do. 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 So on and so forth. Do I have a P for every QRS? Yes, I do. And do the P waves have the same morphology? Now, this EKG, this whole thing is a little bit sloppy because we have just a little bit of what we call artifact going on. It's not perfect, okay? So we just got to kind of get used to looking at all that stuff. So that's your T wave, that's your P wave, that's your T wave, that's your P wave, T wave, P wave, like that, okay? So my P waves, for the most part, they have the same morphology. They're not distinctly different. There's a little bit of artifact, so that's why they do look a little bit different. But there's definitely not 3 or more repeating morphologies. So it's not going to be like a wandering atrial pacemaker or anything like that. All right, so we got P waves, got a P for every QRS. P waves have the same morphology. Let's look at our PR interval. PR interval is about 0.20, okay, 0.20. So that means it's within normal limits, so that's pretty good, okay? Then I'm going to look at my QRS, and I'm going to ask myself, is my QRS wide or is it narrow, okay? So if you go from here to here, you'll see that your QRS is just barely over the threshold of a wide QRS. And if I'm not sure, I will kind of look across some other leads, and you got to look at the big picture, guys, right? So what do we see like going on in AVL? We've definitely got some wide QRSs. V1 got some wide QRSs, okay? So we have wide QRSs, right? Because the next question I would have asked myself in my progression is my QRS narrow or wide? So remember how I taught you guys to ask yourself questions about what you're looking at, like, do I have a P wave? Do I have a P for every QRS? Do my Ps have the same morphology? Does my PR interval, is that within normal limits? Is my QRS narrow or wide? Now we're coming into the part where it's like, okay, now this information that I'm gathering is starting to mean something, okay? So in this particular case, my QRS is wide, okay? So don't know why, we'll figure that out in a little bit, all right? The next thing I'm going to look at is my R to R interval, okay? R to R to R. And I'm asking myself, what? Is it regular or irregular? And that looks like a regular rhythm, okay? So then my rate, not really looking to calculate it at this exact moment, but it's definitely between 60 and 100. So what do I know so far? I have P waves that are present and upright. I got a P for every QRS. P's same morphology. PR interval is good. QRS is wide. R to R is regular. Okay. So I have all of the criteria for a sinus rhythm, but something is a little bit off. We have a wide QRS. So we need to go figure out what's going on with that wide QRS. So if I'm thinking that I might have a bundle branch block because I have a wide QRS, I'm going to go and I'm going to look at my money leads, right? I'm going to look at V1, I'm going to look at lead 1, and I'm going to look at V6, okay? If V1 goes down, a negative deflection, which it does, and then lead 1 has basically an R wave only, V6 has a R wave only, that meets my criteria for a left bundle branch block, right? QRS greater than 0.12. V1 with a negative deflection, lead 1, and V6 with the R wave only, okay? So that is your criteria for a left bundle branch block. So what's happening here? So for whatever reason, electricity is not migrating down that left bundle. So remember, the left anterior and the left posterior fascicle are both blocked in a left bundle branch block because the block is above them, okay? So what would we say? We would say that this is a normal sinus rhythm with a left bundle branch block. That's what we would say, okay? So hopefully that makes a little bit of sense. It just comes with practice. You just got to keep practicing. The more you see it, the more it starts to pop out at you, okay? So, okay, let's look at another one here. We're going to look at money, don't worry. All right, first things first. Do I have P waves? P wave, P wave, P wave, P wave, P wave, P wave. You get the point, right? Okay, P waves are here. Do I have a P for every QRS? P QRS, P QRS, P QRS, so on and so forth. I have a P for every QRS. That's good. What happens when we don't have a P for every QRS? We call those non-conductive P waves. And that usually means a AV block. So a second degree type 1, a second degree type 2, a third degree AV block. Don't confuse a bundle branch block with an AV block, okay? Because remember, if you have the SA node up here and the AV up here, and then the bundles here, in an AV block, the block is somewhere over here, right? But in a bundle branch block, it's below the AV, and it's either in the right or the left, okay? So don't confuse those things. I know they all have the word block in them, but that doesn't mean they're the same, okay? All right, so I got P waves. I got a P for every QRS. P's have the same morphology. Very good. PR intervals look good. Because remember, I'm just really looking to see, are they within normal limits? Are they too short or are they prolonged? Because shortened PR intervals can mean things and prolonged PR intervals can mean things, right? So I'm really just looking to see if it's within normal limits. If it's not within normal limits, is it too short or too long? Prolonged, as we would say. So then I'm looking at my QRS width, and what do we got again here? We got some wide QRSs, okay? So wide QRS, I gotta ask myself, do I have P waves? I do, good. That means it's some kind of bundle branch block. All right, so rate. Oh, no. Yeah, I'm right, my bad. So R to Rs, that was my next step here. I started talking, I got sidetracked. So my R to R intervals are regular. So we have a regular rhythm, okay? And then the next question is going to be, okay, cool. What rhythm is this? So P waves present, same morphology, upright, P for every QRS, so on and so forth. You should know the criteria for normal sinus rhythm by now, hopefully. And this meets all the criteria for normal sinus rhythm, or just a sinus rhythm with some sort of bundle branch block that we know we have, but we don't know which one yet. So let's look. I know I have a bundle branch block. Why do I have a bundle branch block? Because I got wide QRSs and some P waves. So how do I figure out what kind of bundle branch block it is? I go to my money leads, V1, lead 1, V6, okay? All right. So if you look at V1, you'll notice we have a negative deflection. Lead 1, we have a R wave only. V6, we have R wave only. V1 negative deflection. So V1 goes down and then lead 1, V6 are present with Rs only. That meets the criteria for a left bundle branch block. If you're still a little confused as to what the criteria is, maybe just get that picture out and hold it side by side while you're looking at these rhythms, okay? That's what I would advise until you kind of commit it to memory. Because there's just going to be some things, guys, that unless you memorize it, you're really going to struggle with identifying things, okay? So you definitely want to get those criteria for a left bundle, right bundle down pat. And I tell you never to memorize what things look like, but you got to at least memorize what they look like as far as what lead's supposed to be down, what lead's supposed to be up, which one only has Rs, which one has slurred S waves. You just got to kind of memorize that, okay? All right, so we are going to pause this video just for file size reasons. And then we're just going to pick up and continue off literally on the next EKG in a new video.